record on this computer. So we've got ourselves, so I have fixed up the overview for module 2. I'll work on module 3 later, but right now, hopefully you had the chance to look at the videos about the about stuff. If not, that's okay. I'll briefly go over kind of some of the stuff. The gloves are for my skin. The dry weather causes awful things to happen to my skin, and so it helps with keeping moisturizer on my hands. So that's why I've got gloves on. Makes typing a bit difficult, but ever since I've started wearing the gloves, it's been much better. So, okay. So let's see. We've got textbook readings. Why is this? I assume this is what people have been getting for errors. Storage assignment. Yeah. Okay. I'll just simply well, time to fix that. Easy enough. Let's see. So if I'm in that, let's see what happens if I try clicking it now that I'm in that course. Okay. Yep. For some reason, it gave me a link to throw to you. I don't know why. You know what? I'm just going to go into the assignments and just simply say, boop, edit, and I'll take you to the assignment page. Remove link. I said, here we go. Remove link. Remove link. And now they changed it up. I used to just be able to paste on text and it would create the link. Done. Remove link. There you go. Saved, changed. All right, so I had meant to like change this earlier and give you more proper due dates, but I totally neglected to update it until like Sunday, and then also stuff happened with a 4-year-old wanting lots of attention, so it was just a bit wild this week. So anyway, point being is I've got the due dates. You've got chapter 2, which just again, these due dates are very soft, so if you're late, this is more when I expect you to have these things done by. So let's go ahead and talk about programming. Third to last question on exercise 2 is not showing up. That's probably not a problem on your end. I will be more than happy to take a look at it in after class. I will either if you're having issues with that, either send me an email or message me on Discord, and I'll be able to handle textbook stuff after class. So let me go ahead and get started since we only have an hour 20. So here we have, so hopefully you've been to your labs and you've had the opportunity to to mess around and stuff. So this is Idle. Idle is one of the many editors you can use. I prefer Visual Studio Code, but for purposes of teaching, I like this one because it comes pre-installed in with Python. And this is what so Idle importantly has 2 modes. It has this REPL mode, and it has the script mode, which is what you should use most of the time. Okay. So you've got your REPL mode and you've got your script mode. It's perfectly fine if you code in whatever you want. Sublime is perfectly fine. I like Sublime. It's a good text editor, but I really like Visual Studio Code. In my opinion, just very well put together. So, let's see. So now, what's important to understand is that effectively there is no difference between what these 2 different modes can do, right? Anything you can do in this mode can be done in this mode. I'm going to turn that off. That is not working the way I wanted it to. Okay. So anything you can do in this mode, you can do in this mode, except for the fact that basically that you have to run each line one at a time in this mode. So, but the REPL mode, this line where we have the triple signs, is very useful for like explaining certain principles in Python. This is what you want to do in your homework. If I see you copying stuff like this into your script and then wondering why it's not working, that's the reason it's not working. If I see you doing that at the end of the semester, that says to me you've kind of checked out all semester, and that's not great. Totally happened last semester. All right. Anyway, so let's go ahead and talk about this. So I mentioned previously that this is effectively the world's strongest calculator that we have over here. So you can put in any kind of mathematical equation you want, right? And I go over this in the videos, but I'll also emphasize it over here. So 4 plus 6 is equal to 11. Well, actually, that would be equal to 11, but let's let the computer tell me. 5 plus 6 is equal to 11. Why did I say 4? Jeez. Okay. 7 times 2 gives me 14. By the way, spacing doesn't really matter in this mode. Right? It still interprets it just fine. It's not really too much about it. So it works with the standard operators that you would expect, with some caveats, right? What's the caveat about doing division?
Can't really divide by 0.
What? Well, how many types of division do we have in Python?
Oh, like 2.
We have 2 types of division.
Yeah.
Right? What are those types of division?
Like the ones where you divide integers and the ones where you divide like doubles. And if you divide integers, I think like the answer will also be an integer. So I think like 1/2 would be like 0 or something. If you did integers.
You're close. In Python, it works differently than other programming languages, specifically that because they didn't want to confuse beginners. So let me explain the way it works in this programming language, which is that division is often messy. So if you divide, you'll always get what's called a floating point numbers. You see, Python has 2 different ways of storing numbers. You've got your integers, and you've got your, which are those whole numbers that we're so much more comfortable with. And then you've got your doubles, which are a standard way for computers to translate 1s and 0s into decimal points. I say standard way because you'll see that it doesn't always work 100% of the time precisely, but it's close enough. But anyway, so 7 divided by 2 gives you 3.5. Notice that doing 5 divided by 1, right? We would normally say that would be 5, but because anytime you divide, you do a division sign, a single division sign like this, you are going to get 5 divided by 1 or 1.0. Eddie, I very much appreciate the Bill Verts in the background. So.
Thanks.
All right. So the, so notice that we get a 5.1. Now I say there's 2 different types of division. And because this is the way we would assume that things should work in a programming language. 89 divided by 3 gives me 29.6666, what now? 6.8? Any suggestions as to why we might be having a 6.8? So why does math not only work in this version? Well, this is a read, evaluate, print loop, a REPL. So if you want to do it over here, so let's go ahead and drop it on my desktops, math examples. I'm not going to call it math because that could do weird things, but math examples. Okay, I'm going to put it on my desktop just to store it there. If I do 4 plus 4, yes, you're exactly right. Running this, which I just did by pressing F5, did nothing, right? And that's because over here, it will just evaluate it, but it won't print it out unless you tell it to. This one will print out the result of every line. So here, if I put print around it, so when you're working with an actual script, you tell it to print it out. Here in this mode, it assumes you want stuff printed out. So it will print the result out for you automatically. Right? This is basically you directly asking a computer a question. Here you're writing a script. Okay. So, right, we've got our numbers. Again, my videos go into this in more detail. The other type of division we do is integer division, which is actually quite useful. And it's part of the reason we keep it around, which is just basically doing division with whole numbers. So, and it works and it looks weird. Two divide signs. So 10 divided by 2, 10 divided by 5 is equal to 2. Right? It gives me 2 as opposed to 10 divided by 5, which gives me 2.0. Right? So if you want a whole number, which you do sometimes, you can do it like that. But what's important to note is how it works, right? 11 divided by 5 is 2 and a bit, right? 2.2. 11 divided by 5, it just throws out that a bit. So when you do integer division, all it's going to do is just toss out any decimal points. It's not going to bother doing any rounding whatsoever. Although if you want to consider doing rounding, it's always doing rounding down, right? But it just kind of just ignores the decimal point. Okay. Now, why do we care about this? Because often it's useful for, like, say I want to get the thousands place. The easiest way is to just divide by 1,000 to do integer division by 1,000, and boom, got the 3 right out there. And then, yeah, it gets into that with modular division with modular arithmetic as well, which is the other big thing. It's also very useful for doing things like this. If I want to just get everything but the ones place. So if I just want to toss out the ones place, 3102 divide by 10, that tosses out that. So there are two kind of unique, there's one, so before I move on to the unique operator we get in programming, I want to point out that how exponentiation is written in Python. Which is that if you want to do exponents, say 2 to the 8th power, you won't write it like this. That is not 2 to the 8th power, right? That's 2 to the 8th power should not be 10. This is because this is actually a different kind of operation that works off of binary numbers. And it's kind of got precedence, so to speak, in the computer science world that basically that symbol means a different symbol, XOR. So we're going to instead for Python, they rather than having you do a function, they just simply say, well, we'll just do 2 multiplication signs for exponents. So 2 to the 8th power is 256, right? So if you want to do exponents, right, 2, so let's do a 10 cubed, right? 10 times 10 times 10, that's 1,000, right? So it just kind of, so you got exponentiation built in, it's just 2 multiplication signs. Now, the last unique operator we have in Python is the modulo operator, which looks like a percentage sign. That's how it's written in Python. That's the symbol we use. Modular division is basically goes along with this integer division. It's the remainder. Okay, so think of one way to think of it is that doing divide is like doing 4th grade arithmetic. So right, like 65 divided by 2 gives us a quotient. Whoops, unexpected indent. It does not like you doing stuff. It does not like starting with a space or anything. So 62 divided by 5 is equal to 32. That's the quotient. But what is the remainder?
1.
1, right? The remainder, not a trick question here. The remainder of 65 divided by 2 is 1. So this is a pseudo lie. It's not untrue, but serious mathematicians will groan at me for using for saying this. But this essentially is the remainder operator. It gives you because that's effectively what this does. It gives you the remainder. 65 mod 2 gives you the remainder of that. So if I were to say 147 mod 10, what is the remainder of 147 after being divided by 10? 7, right? Would be 14 for the quotient, and then 7 would be left over, right? Okay. Another one, one of my favorite questions to ask on real exams when I have a lot of students. When I have well, actually, let's do another warm up. 232 mod. Well, actually, let's move on to this. I need to show you some more cases. 2 mod 4. How much is the remainder of 2 after it's been divided by, 4 after it's divided by 2?
0.
0.
0.
4 mod 2 is 0. There's no remainder left. 5 mod 2. 1. 6 mod 2. 0. Useful property of this is that basically that any even number, you can just mod it by 2 and it'll be 0. Any odd number, it'll have a remainder of 1 after being divided by 2, right? 2 even numbers are evenly divisible by 2. I mean, no, you need both lines, I believe, to get both the quotient and the remainder because you need 2 separate answers. But the point being is that it's not you generally just want one or the other. You don't need both generally. The modulo operation is useful primarily for using mod 10 and mod 2. That's the times we're pretty much going to use with it. One property to know about modular arithmetic is, let's say I can write really complicated looking questions that are not really that complicated. Like this. Anyone want to guess what the remainder of 34 mod big giant number is?
34.
Yep, 34. The remainder of anything modded divided by anything else that's huge is going to be the original number because the quotient would be 0.
I just screamed this out to myself, Professor. I'm just thinking, how though?
How?
Yeah.
How what? How does it calculate it? Because your guess is as good as mine. I don't really go into. Actually, it's weird. Actually, the way it would work is subtraction and checking stuff. But
subtraction and checking. This has nothing to do with division or percentage calculation.
You got to remember that all the so percent doesn't mean anything, right? It's just the symbol here.
Oh, okay.
So it has nothing to do with the percentage sign. This is just the modulo operator. We just only have so many keys on our standard keyboard.
Okay.
Okay. So the percent sign we use is the modulo operator, much like we use the star for multiplication, even though it's an asterisk.
All right, I see. It's just that I've never encountered, I guess, mathematics.
No, this is the only place. This is the first place you should encounter it.
All right.
Okay. Yep. So, now when it comes to the now, did you have a question about the remainder, or about that operation, or with terms of how the computer actually does this? You got to remember that computers can only really do. They only store zeros and ones, and then with the zeros and ones, they can only do 2 things. They can compare a pair of zeros and one of strings of zeros and ones. So it can compare 2 numbers, or can add 2 numbers. Subtraction is just addition, but with negative numbers. So long as you encode you've got the ability to do negative numbers. All subtraction is adding a negative number. So multiplication is just adding a bunch of times, and then what division is a bit more complicated, but basically it's counting the number of times they can subtract something. So that's a bit more deeper into the hardware level than I like to go. The computer's here to do all that dirty work for us, right? And yes, Isaac has got it right in there. So one of my favorite questions to ask on an exam is kind of the reverse. On a standard exam, I would ask this on a, what is this? What is the this evaluate to?
Zero.
Yeah, 0. It's 0 because this is a big number, but it's an even big number modded by 2. So the remainder is going to be 0. 0 multiplied by anything is 0. Right. I like to make generally I would, if I was writing a real exam, I'd like to make things seem like that look scary actually be 1 or 0. Makes it easy to grade too. So, but this is just simply calculator stuff. What makes this really powerful is the use of variables. So first, I mean, you might have, but I give a practice exam with a very similar question generally. So common thread in computer science is that things are is that they look more complicated than they are actually. Remember, we're just working with a rock we shot with lightning to trick it to think. So computers are dumb. You can outsmart them. So variables. So this is written x is equal to 10. And we'll often say we set x equal to 10. And what's cool is now if I do x, it will retrieve the value 10. If I say x plus 1 gives me 11, x plus 2 gives me 12. If I say x is equal to 16 or 16, it's now going to store 16 in that value, x. Now, what's important is that this is not setting up what I refer to as a hard binding between the values 16 and x, right? Because I can change this. I can say x is equal to 20, and that doesn't make 16 equal to 20, right? What this is actually a fault of, again, using the symbols that we have on our keyboard to mean something else. What we really mean is that when we write this equal sign is we use it, it's called the assignment operator, which means that we store we take what's on the right, we take it on the right and we store it in the left. Okay. So unfortunately we can't write it like this, even though what we want to do is kind of like draw an arrow, because we look at that and go, that's less than negative 40, which is not really what we want. So we can set, so we thought, okay, and if we try to draw an arrow like this, it doesn't really, we get the same kind of thing. X is less than or equal to 40, right? Some programming languages thought, okay, well, because I don't want to say, misread it and make you think X is equal to 40. It's more important when we work with other variables, but I'll get to that in a second. They did something that they called the Walrus Operator, because if you turn your head sideways, it kind of looks like a walrus. And eventually that just got shortened to this. And what this did, so what is this equal sign? In computer science, this is the assignment operator. It takes what's on the left and stores it, takes what's on the right and stores it in the variable on the left. Variables can have pretty long names. So I can do x plus my awesome var. There are a couple restrictions on what you can call variables. Like, for instance, you can't name it, you can't start a variable with a number, right? So you can't start with a number. Variables have to be made of, they have to be made of letters and numbers and the underscore sign. So, and you can use capital letters if you want. And again, I go into detail that in more in the videos. This is more just for review, to because I'm aware that with the first week, not everybody's gotten it. People have just joined. They may not have realized what they have to do yet. and not necessarily watch the videos yet. And, you know, I've got actually plenty of time to get everything I want taught to you. So I'm fine with taking my time to do that. Now, what I was talking about with this hard binding, again, this is something that I go into detail in the videos. So if you're not having trouble with this, get back to me on Thursday after you've watched the video. Let's say X is equal to 7. Y is equal to 8, right? So no, nothing tricky here, right? Nothing up my sleeves. Don't have any sleeves, right? X is equal to 7. Y is equal to 8. Nothing scary there. Okay. Here's where I'm going to say Y is equal to X. Okay. Y is equal to X. And now I say X is equal to 10. What is Y's value at this point?
10.
Why is it 7? It is 7.
Because you set X equal to 10 after you made Y equal to 7.
Right. There's so the two answers to this should be either 7 or what. So, you know, so if you got 7, great. You were listening to what I said and recognize and listen to what I said earlier, that basically that we use operators in a different way than we do in algebra. If you're going what and are confused, that's perfectly fine. That just means that you've got all the rules that you've got ingrained from algebra still with you, which is perfectly fine. So remember what I said. This means take what's on the what's on the right and store it in the variable on the left. So think of these variables as boxes. And I think now would be a good time to grab this, excuse me, plug in the webcam tablet just to draw this. Let's see. There we go. I know, super
I also
organized.
use a Wacom tablet.
It's I got it at the beginning of the pandemic. Been very useful. My handwriting is terrible, even without even considering that I'm on a computer. So let's go ahead. I'm just going to draw straight on rather than opening up a new program. Annotate. Great. Okay. So what we've done with this line over here simply says, hey, I'm creating a box. I'm going to give it the label X, and I'm putting a 7 into it, right? Then I've got a box. Then this line over here says, I've got a box called Y. I'm going to give it the label 8. Got a box. Going to give it the label Y, put an 8 in it. This line over here and this line over here don't matter. We're just checking the box, so to speak. This says just simply print out what's in the box, please. Now over here, X is equal to Y. What is inside of X? What is stored inside of X? 7 is. So we're just simply going to replace that with 7. So now it says, take the variable, remember, because this is always take what's on the right and store it in the variable on the left. Make sense? And I believe so. Alex, I haven't had the chance to read it, but I will. So store it in there. So what that does is that this stores Y in there. Or it's not store Y, it stores 7 in Y. I'm trying to think and talk and draw at the same time, not working out too well. All right, now this line, what it says take the 10 and put it in the box labeled X. Right. Now, Alex is saying if we were to reverse these two lines, right, and do the X is equal to 10 before we did that, before we did any of this craziness. So we had 7, we put the 7 in X, the 8 in Y, and then Alex was saying to me in a private message, so that we would do, if we did 10 before this line, we did this line first, put the 10 in here, then what would happen is that we'd say X, Y is equal to X, this would store 10 in here. What's important to realize is that changing one of the values in this variable does not change the other one, right? Changing X and Y has no bearing on the other one. These guys are, they live their own independent existence. They're boxes we're just putting stuff in. It is not a hard binding. It is a copying operation. This copies the value from one side to the other. Does that make sense? We're copying stuff when we do that equal sign. That is possibly the, now why does it work like this? Because we can put way more interesting things inside of variables than numbers. That's why. And those very more interesting things, it's tough to keep track of them sometimes. So let's go ahead and see what other interesting things we could put in. We could make, for instance, word is equal to hello. And if you watch the videos, you'll see there are interesting things we can do with words. Like we could do word plus world, space world, and it will do, so adding together has its own operations. These operations are actually fairly straightforward and are not scary at all. In fact, there's only 2 operations you can do on strings. We do not need the print thingy when we are working when we work in the REPL, so any of these lines where you've got this, it's assuming that we don't need the print. Over here though, if we're writing a script, if I were to do word is equal to hello, and did word over here, wouldn't do anything. We got our 8, but we didn't do anything. It would take printing this out to get to do this. Make sense? So what other things can we put in variables? Well, pretty much everything in Python is what we call an object. And I'm going to introduce you to one of my favorite objects of all time, the turtle. Now, I'm going to have to say a few magic words here just to explore, because all today is about is kind of like different kind of really awesome things you can do, but also like just how scripts work line by line. So first thing I'm going to do is do import turtle, and something magical should happen pretty soon. Let's see. So import turtle, and I'm going to say another magic line, and I'm going to go ahead and make Bob. I'm making a variable called Bob over here, and I'm going to say one more magic line, and that should be all the magic I need. Okay. And by magic, I mean you have no idea why I have to say this and why I have to say this. Okay, that's what I mean by magic. Haven't explained it yet. Importing comes later, and this kind of call over here, turtle.turtle parentheses, and one is capitalized, and that apparently matters. So important note, things are case sensitive in Python. That means that there's a difference between apple and apple, right? One is a company, one is a fruit. So, and if you were a student, you notice that this kind of popped up in the background. And so we've got this thing over here. This is my turtle named Bob. Say hi to Bob. He looks like a little arrow right now. Let's see, Bob, can we make you bigger? Bob dot, what is it? Set. Let's see, shape size. Yeah, let's make it 2 by 2. There you go, a bit bigger. If Zoom is crashing for you, that is because there is most likely still residual issues, which I was waiting to hear about. There's probably residual issues from somebody tripping over a cable in New York or something. Like somebody says that Verizon says a line has been cut in New York. So if there's difficulties today and you're unable to participate in the exercise that we're going to be doing shortly, that is perfectly fine. So this is Bob. he's a turtle, and turtle is one of these wonderful things from the 1960s. It was a programming paradigm designed to help basically originally envisioned to help learn children how to code, but eventually was expanded. And I did a lot in my I use these things a lot in my PhD simulation class because turtles are very useful paradigms for programming simulations. And what, you know what? He doesn't really look turtle-like. Bob dot set shape turtle. I think that's how you do it. No, attribute set shape. Was it just shape? There we go. Now he looks like a turtle. So very simple. Turtles are very simple. We're looking bird's eye view down at Bob right here. Okay. Then we can just give him commands on how to move. Bob.forward. Let's tell you to move 100 pixels this way. Just move forward 100 pixels. And notice he created a little line as he drew. Now, the way we envision turtles is that he's on this giant white piece of paper. We're looking down on him, okay? And all we have to do and all he's got a little pen in his mouth, and he's dragging along the paper as he moves. So then we can draw graphics by telling him to do things like, hey, Bob dot right 90. So forward tells you forward and backwards tell you how much you want him to move. And then we can tell him right or left to make him turn. Very, very simple kind of paradigm there. Okay. So now if you go ahead and open your textbooks, right? This is actually a much more interesting statement than most times professors tell you to open your textbooks, right? So go to runestone.academy. And one of the reasons, this is one of the things that like really got me all aboard Runestone was if we go to project 2, driving the turtle, right? This activity is designed to get you learning some cool, interesting programs. And what we're going to do is that a lot of what we're going to do today, we're going to go into deeper detail about turtles, by the way, in their own chapter. Like chapter 5 is all about doing turtles, because turtles are great tools because you get to visually see the instructions you are running. Right. But we can run this in your web page. So I just ran that here and it did that. So turtle, import turtle, the magic word. My turtle is equal to turtle.turtle. He just called it my turtle rather than Bob. I like Bob because it's 3 letters long, to be honest. That's why I like Bob. We set so then he's got some other commands. My turtle is dot color, and he's got some comments over here. Right now, for those of you who missed that earlier or didn't, or a comment is a pretty useful thing. Comments are not meant for the computer. They're meant for flesh and blood organics like ourselves. They are meant for the people who are reading, for anybody else who's reading code, they're kind of an explanation. If it sees the hash symbol or a pound sign or a bang or a crunch, as it's sometimes called, does it have settings for other animals? You can use, there's ways to change the picture on your own computer. If you have images. In fact, we will do that later with a hurricane tracker program we write. But right, and that comes much later, by the way, when we do file reading. So my turtle color, this sets it equal to green, and this line over here does not get read by the computer. This part does not get read by the computer. It gets read by humans. So my turtle forward 50, that's what this first line down here is. That drew this little line over here. Then we had 2 more commands that I haven't gone over. Up, lift up the tail. My turtle down, put the tail down, right? His pen is on the tail, so if he lifts the tail up, he's no longer drawing. And my turtle down, which puts it down. How do you guys get the import turtle? Mine says invalid syntax. For right now, Jacqueline, I'll be happy to help you afterwards. For right now, I highly recommend working in the textbook. It will save your work for you, and then I can diagnose your system after class. So, so what we want to do today is pretty straightforward. I want you to take this and have fun. I want you to kind of look at what you can do over here to draw things, right? Explore a bit, figure out what you're doing. Now, for the people who are having issues with importing a turtle, couple questions. And so you can go ahead and get started on this but basically we have a couple of just let me know what operating system you're working on if you're having issues in the chat. Next, here are our instructions. So the dot after the my turtle variable is a command. This is week 2, part 1. So you do this inside of here and your work gets saved in here. There's no need to submit anything to me. So, and you can, and by the way, you're asking which link you should click. So it doesn't matter. It doesn't matter. Whatever you do on this page or gets linked to whatever you do on this page gets linked and saved over here. So it doesn't matter where you do it. In fact, it's probably better if you do it in here. So you've got more stuff. So it's very nice like that. It links all that stuff together. So if you're going through and doing the exercises in the textbook, it links those exercises automatically if they're ones I assign. So, so you've got a couple of different commands you can do. You can go forward, backwards, left, right, up, down, color, different ways to change the command. And all the commands, by the way, they always end with parentheses. That's how they know. Oh, that's how Python knows it's a command and not a variable. Make sense? So if it needs more information, you put it in between the parentheses, such as like how much you want to move forward or how much you want to turn left or right. Now, if you want to learn more about commands that turtles can do or anything in general about Python that's built in, you use this magical Google phrase, Python, thing I want to know about. So I want to know about turtles. And then either docs or documentation. That is the magic Google phrase. Generally, the first link will work. Turtle graphics. Here's a small program, for instance, that draws this thing above. And these are, in fact, all the different instructions that a turtle can do. If you beyond what you want, again, we will go into way more detail about these, but if you want to try doing something in the exercise over here. Oh, yeah, I have plenty of time. So let's go ahead and take some time to do these. And then perhaps if people come up with something pretty interesting, they can share it with the class. So that's voluntary. I'm not going to call on anybody and put them on the spot because that's mean. Okay. So let's take some time. And then I'm going to go ahead. So Kamari, Thomas, are you two still having issues?
I had issues when doing it initially in idle. It's just that when I tried putting the information in, it kind of, I don't know.
All right. So if you're having issues with Turtle in idle for some reason, I'm going to create a breakout room very briefly. Going to create one breakout room. And I'll just simply jump there so that we aren't going crazy with, just flashing our screens at everybody. So, okay. Yeah. One breakout room, rooms are open. You can join yourself. I'm going to go into that room if you need help to, if there's something weird happening that you can't identify. Okay.